This is the video explaining vectors. So here we have a question, and it says that in the diagram above not drawn to scale, A is the midpoint of OB. So we have the diagram here. We just note where it says that A is and that that's the midpoint. Then it says vector EC. So from E to C is half of OE. So from O to E. So EC is half of OE, which would mean that we could fit another EC somewhere in here. So in all, this entire length right here would have an EC here, length EC also there, and a length EC there, right? So in all, this entire length would be 3 ECs if we consider that EC right here is half of OE. Then it says that ED is, so that from E to D is equal to 2A to E, which is a similar concept to what we just marked on it. What it's basically saying is that if you go from E to D, you'd have gone double the distance of A to E, right? Or in other words, 3 AEs would fill this entire space. So AE here, and then AE there, and then AE again. Whatever those vectors are, we can use those properties to help us to answer these questions. And finally, here it says that the vectors UV are such that OE, so from O to E, is equal to 2U. So let's write that down. So from O to E is equal to 2U. So we have that right there as 2U. And then it says from O to A, that's V. So that's described by vector V. Okay. So we're now going to answer these questions. So the first one says we should write in terms of U and V, A, E. So remember our vectors, we have to travel along known paths, right? We have to travel along the paths that we know. And vectors have both magnitude and direction. So the original vectors would have had their directions given. You can see the arrow here pointing from O to E. That means that from O to E in that direction is positive 2U. And for this one, from O to A is positive V, right? So the vector is going in from O to A. However, if we're going to answer AE, we'll have to go from A to O, then from O to E. We don't know what this path is. It didn't give us a vector value for that. But the vector values that we know are from O to A and from O to E, right? But remember, we are traveling from A to E. So we'll have to go back to O from A and then up from O to E. So what this means is that we'll go from A to O and then from O to E. And because we're going the opposite direction of the vector, it will be negative V, right? So it's with negative V. Positive V is OA, so AO would be negative V. So we'd go from A to O and then from O to E, which is positive 2U. So that would be the answer for that one. Let's do A to D now. So if you take a look, we scroll down from A to D. All right, so we've already described the vector A to E, right? So if I add negative V plus 2U, I get AE. But remember earlier, we had said, based on what we know about AE, 2 AEs make up ED, right? From E to D. Or in other words, if I go AE, then I go AE two more times, I will reach D, or the vector that is. In other words, A to E, we already know as negative V and plus 2U. If I go the vector AE again, I'll reach here, right? And if I go the vector again, I'll reach up here. So in other words, this entire length from A to D has 3 AE vectors in it. So what I can write that as is simply 3 AEs, right? And we know that AE is negative V 2U, right? We can expand that as, if we expand this, we'd get negative 3V, and 2 times 2U would give us 6U, right? If we want to expand, we can leave it like this though, but that's what we would get. And for III, we have BC. So we're going from B to C. All right. So we don't know this path here. So we're going to have to go this way, then go back up that way. All right. But if we can recall from the very first point, it says that A is in the midpoint of OB. So if A is in the midpoint of OB, it would mean that this right here, this point at A, is half the distance or half the vector from O to B. So in other words, from A to B would also be V, right? So if I'm going from B to C, remember that's what I want originally, from B to C, I'll have to go first from B to A, then from A to O, then from O to E, then from E to C, right? I have to go that entire length. Right now we can see that this would be 2 negative V's from B to O. So it would be negative V, right? Then from O to E, it would be 2U, as is there already, plus 2U. And then from E to C now, which we haven't described yet, but here we see it where it says it's half of OE, right? EC is half of OE. All we need to say is OE divided by 2, right? So if we divide OE by 2, we'll find the vector for EC. So 2U divided by 2 is simply U. So that would just give us plus U, which would give us, would get us to EC. So simplifying this, we get negative 2V plus 3U, because this is 2U plus U, which is 3U. So this was number 3. So negative V plus 3U. Let's write that in. Right, so negative 3V plus, negative 2V plus 3U. And finally for IV, we need to find what CD is. All right, so if we look here now, we'll see where C is and where D is. All right, so there's not even any line from C to D. So what we'll need to go is from C to E, right? From C to E, then from E back up to D. Remember we had said that from E to C would be U. So if we're going the opposite direction, that would most definitely have to be negative U, right? We're trying to get from C to D for IV, right? So what that would give us is from C to E, right? And then from E to D. We said from C to E would be negative U, right? And from E to D, it's 2 times the length of AE, or 2 times the vector of AE. We know that AE is negative VU because we got that from the first question right here, negative V2 2U. So all we need to say here is ED would be 2 times that. So it would be 2 times negative V plus 2U. Can also simplify this. So negative U plus 2 times negative V would be negative 2V, and 2 times 2U would be positive 4U. We can group the like terms. The U here is common. The U right here, negative U, is common with the 4U there. So we just say 4U minus U minus 2V. And 4U minus U would be 3U minus 2V. So that is how we'd get what CD is equal to. So CD is 3U minus 2V. And that's it.